The most interesting thing about this gimbal UFO footage is the rotation. Now, I've explained before how this can just be a rotating glare caused by the way the camera is mounted on something called a gimbal mount. No coincidence. But if the glare is rotating independently of the horizon because of these camera movements, then shouldn't we see other light effects also rotate? In the nimitz, or tic-tac footage, we see a fairly dramatic rotation of both the object position and what looks like some reflected lights over the whole frame as the camera traverses from -3 degrees to +3 degrees, which is where a different rotation mechanism is used and the main gimbal system does a large correction, as I demonstrated in another video. That demonstrates that it's the camera rotating in the nimitz footage, but can we see this in the gimbal video? Yes, we can. I've been using the version of the video that the New York Times put out in December 2017. And if you scrub back and forth with that, you can kind of see the background rotates when the glare rotates. That's evidence, but it was never that convincing because of the quality of the video. But today, I discovered that the New York Times has a higher quality version of the video, which they posted in May of this year, 2019. The older video was encoded at 3.8 megabits per second, but the new video, which also includes the Go Fast video, is encoded at 12.4 megabits per second, more than 3 times the data rate. If you compare the two, you can see there's much more detailed contrast in the background when you zoom in. Unfortunately, they darkened the lower portion of the video, but we're really only interested in the glare and the sky. Now when we scrub back and forth with this new version, you can see the rotation of the light pattern more clearly. But more importantly, the increased bitrate of the video allows us to better enhance the contrast and see this rotation even clearer than before. It might be a bit hard to see what I'm talking about. What is rotating? In an enclosed moving camera system like this, you've got two types of light which make up the final image. You've got the wanted light, the light from the scene that goes through the lens as you would expect and makes the picture. But then there's unwanted light, glare, lens flares, diffraction effects and reflections. That's added on top of the image. So if we rotate parts of the camera, then some of the unwanted light can also rotate. Here you see the faint bands and regions of light and dark rotate with the glare in the middle, and that's what you should look for in the gimbal footage. This rotation of the light across the sky matches the rotation of the glare, the supposed UFO, which proves two things. Firstly, it proves the rotation is caused by the camera. The abrupt rotations of the UFO match the rotations of the light field in the sky perfectly. There's a large rotation here, then the second rotation, then there's a jump at 3 to 4 degrees, probably caused by the large outer gimbal correction. Secondly, it proves that the shape of the UFO is largely, if not entirely, due to camera glare. We've seen this type of glare before in other videos of engine exhaust, and since it rotates with the camera, that means the entire effect is just a camera artifact. Is it solved? Nearly. We still don't know what this is, but the shape is solved, the rotation is solved, and the glow, the aura, is also solved. So all we are looking at is something hot, something like a jet engine miles away. There's nothing to indicate any kind of advanced technology or aliens. This all raises a question. If the New York Times, and especially the To the Stars Academy, had this higher quality footage all the time, then why didn't they release it? Why just put out a low quality version? Didn't they want people to analyze it? This is the nimitz UFO footage, also called FLIR or tic-tac. It's less interesting looking than the rotating gimbal footage, but it gets a lot of interest because of the testimony of Commander David Fravor, who describes a bizarre encounter with a 40-foot tic-tac shaped craft that ran rings around him before shooting off at hypersonic speeds. This video is not of that incident. It was shot shortly later by a different pilot in the same group. But what does it show? To understand the footage, you've got to know that there's actually two cameras being used, and the video switches between them, as well as switching zoom levels. It starts out in infrared mode, where white is hot, and we can see a shimmering heat source. 18 seconds in, they switch to the TV camera, which is just visible light. We can just see a blurry shape in the distance. At 41 seconds, it switches back to infrared, and we'll discuss that later. But for now, I'm going to focus on the TV footage, the visible light image. Here we see a dark blob. wider than it is high, and initially a little like a tic-tac or caplet shape. But over 20 seconds it gets larger as the jet gets closer, and the shape shifts a bit, almost as if it's rotating about the vertical axis. It becomes a little more peanut-shaped, and a kind of tail seems to appear on the left. So what is it? I think it's a distant plane, flying at a bit of an angle to the jet and slightly above it. We know the camera's angled up at around 5 degrees at the start. But how can a plane look like a black blob? Well, we know planes can look very dark when backlit. And we know things tend to look like blobs when they're far away, especially in low-resolution blurry footage. So let's take a plane and see what it looks like, backlit in low-resolution blurry footage. Here's a typical passenger jet, a Boeing 767. If it's backlit, it would look more like this. Of course, what we're seeing is out of focus, so a bit more like this. And not only is it out of focus, but it's also low resolution, so let's do that too. Finally, there's a bunch of noise in the video. Let's have a look at that. So now we've got a simulated visible light image of a distant jet at various angles. We can see that from this angle, it looks a bit like the UFO at the start of the TV segment. And from this angle, it looks a bit like it does at the end of the segment, with the more peanut-like shape and the hint of a tail to the left. So if this is all we had to go by, I'd say this fits pretty well. So maybe the Nimitz video is just a distant passenger plane. But what about the infrared footage? That's showing the heat from the engines. And we saw in the Chilean Navy UFO case that the glare from the engines can hide the shape of the plane. At the start of the video, the Nimitz infrared glare doesn't have a good shape, as the plane is so far away. Later we see more of a horizontal shape, similar to the black shape in the TV footage, but smaller. By the way, this case, the Chilean Navy UFO, is a great example of how experts get things wrong. The pilots thought they were looking at something small and close, but it was just a large passenger plane over 80 miles away. They then spent 2 years investigating it, and eventually declared it a genuine unidentified, only to have it identified a week later by people on the internet, including me. Here's some infrared video of a 767, shot from the front, getting closer to the camera. Like in the Nimitz video, at first it just looks like a dot of light, but as it gets closer we get more of a horizontal shape as the engines separate. So it certainly could be the same thing in the Nimitz video. Unfortunately, they've cranked up the sharpening in this video, giving it a strong aura like in the gimbal video. What are the sudden movements of the UFO? They appear to all just be camera movements. There's a rotation when the camera does a gimbal lock correction around 3 degrees, and the other movements all coincide with changes in zoom. Finally, the camera does a zoom change and just does not lock back onto the object, and it drifts off as it's not being tracked. A final zoom change gives the illusion that it's moving off really fast, but if you correct for zoom, you see that it's actually not. Is it solved? No, not 100%. The fit is pretty good, but not exact. But this was just the first plane I tried. Maybe a different plane or a different camera setting will work better. But I think it shows that a distant plane is a very real possibility that should probably be at the top of the list. And again, this isn't the same thing that Commander Fravor saw. So this just being a plane doesn't mean that he didn't see a giant jittery tic-tac shaped craft. I don't know what he saw, but I know what this video looks like. It looks like a plane. Episode 4 of the History Channel's show Unidentified Inside America's UFO Investigation centers around 3 videos, commonly referred to as Nimitz, Go Fast, and Gimbal. All 3 videos were extensively analysed on Metabunk over a year ago. Nimitz is probably just a distant jet. Gimbal is also probably a distant jet, but this time with a rotating glare that's just an artifact of the gimbal-mounted camera system. But what I want to discuss here is the Go Fast video. This video appears to show an object flying very close to the water, which is how it's presented on Unidentified.
That thing is hauling
That's
ass.
exactly my point.
It's a little less than 2/3 the speed of sound.
This description is repeated on the To the Stars Academy page, where the video was first released. A white oval shape moving at high speed, flying very low over the water. But is it really low and fast? No, it's not. It's actually high and slow. And we can prove this with the information in the video. There's a bunch of numbers on screen. The altitude of the jet is pretty constant at 25,000 feet. The calibrated airspeed in the lower left is also fairly constant at around 255 knots, which gives a true airspeed of 370 knots when you correct for the 25,000 feet pressure altitude. The jet is flying straight at first, but after locking on, it banks about 13 degrees to the left. I extracted this information by feature tracking the ends of the horizon line, so the jet's turning a little bit to the left. The number at the top is the angle of the camera relative to the front of the jet. It goes from 35 degrees left to 58 degrees left. The number in the middle left is the camera's downward tilt. It goes from 22 degrees down to 35 degrees down. One of the more important numbers here is the range number, on the right-hand side, labelled RNG. This is the distance to the target in nautical miles. It does not show up until the target is acquired, but then it goes from 4.4 nautical miles to 3.3 nautical miles. So we can use all these numbers and how they change over time to do two things. Firstly, we can calculate how high the object is. That isn't too complicated. We know the angle the camera is looking down at, and we know the distance to the object. So the height of the object below the camera is really just simple trigonometry. It's the range multiplied by the sine of the downward angle. If you take the object at the start and the end of the tracking, we get 4.4 nautical miles times the sine of 26 degrees gives us 1.92 nautical miles below the plane. Then at the end, 3.4 nautical miles times the sine of 35 degrees gives us 1.95 nautical miles, about the same. Then it's an object that's around 13,000 feet above the water. And it's also being viewed from a jet at 25,000 feet. So basically it's halfway between the jet and the ocean surface. This is very important because it means the perceived motion of the object against the ocean surface, even if it were moving very slowly, or even if it were not moving at all, would be the same as the speed of the jet itself. This parallax effect is hugely magnified by the high zoom, which is set to NAR, narrow, or around 1.5 degrees field of view. So, we've already seen the unidentified analysis is wrong. It's not close to the water at all. It's at 13,000 feet. But is it, as they say,
It's hauling
That's
ass.
exactly my point.
It's a little less than 2/3 the speed of sound.
hauling ass and 2/3 the speed of sound? No, it's not even close. It's going as slow as 20 to 40 knots. Just wind speed at that altitude. We can determine this with some slightly more complex analysis. So we know that the jet and the object maintain constant altitudes. The object at 13,000 feet, the jet at 26,000 feet. So we can restrict the analysis of the speed of the object to an overhead view. Now, given the range and the angle relative to the front of the jet, we can plot an initial position for that object relative to the jet. Then we know the speed of the jet and the time of the locked portion of the video, so we can plot where it will be at the end of the video. Then using the final range and the angles, we can plot the end position of the object. We can then divide this distance traveled by the time and we get the speed of the object. This depends on how much the jet is turning to the left, but putting in a reasonable turn rate and we get the object speeds in the range of 20 to 40 knots, maybe a bit more, but it's all consistent with wind speed at 13,000 feet, not another jet, and certainly not 2/3 the speed of sound. We can also make a rough estimate of the size of the object based on the field of view, the range, and the fraction of the field of view covered by the object. This gives us a size of about 6 or 7 feet, about the size of, say, a weather balloon. In Unidentified, they notice that the craft appears cold on the infrared, and the narrator says,
There is no known aircraft that can stay aloft for long without a source of lift and propulsion.
which is false, because there's an obvious type of aircraft, a helium balloon, which appears cold in infrared and can stay aloft for hours, even days. It can also look like it's moving really fast over the ground when it's actually just parallax. Here's another example where a balloon is clearly just a balloon, it's also barely moving, and it looks like it's moving really fast. Balloons themselves don't reflect radar, but weather balloons carry radar reflectors, which will be very easy for the range-finding radar to lock onto. And finally, in the Defense Department's Form 1910 that authorized public release of this video, the description specifically mentions balloons. Does this solve this one particular video? Not 100%, but it's a quite plausible answer that people are ignoring. Maybe they just didn't do the math, maybe they didn't like the answer, but you can't ignore it as a possibility.